Good morning, students. So we'll move on to the next topic, basic input-output operation. So from this topic and from this block diagram, okay, we can easily understand how the input will be processed by your processor and how it will be displayed in output unit, right? So this is what the block diagram, basic input-output organization. So we got a bus structure, right? Along with that bus structure, we are connecting total three different functional units. One is processor, second one input, and third one output exactly. Fine. You can observe we are using the buffer registers for both input and output unit over here, data in and data out. Okay. So this we already know from previous topics. Okay, while discussing about the functional units and all, buffer register is must. Okay, why? Because we got a drawback of using single bus structure. Only two units can be active at a time by using this bus structure. So meanwhile, if any devices want to communicate with bus cable, then it will be not available for the communication. Okay, so that's why what we need to do, we need to provide a buffer register so that whatever the information we want to communicate using the bus, that will be managed temporarily in this location. Okay. Finally, when the bus line get clear, okay, then the content will be uploaded to bus. Finally, it will reach the destination. Finally, task will be completed. Okay. So that is what the benefit of using buffer register in keyboard and display. Okay. Like other than keyboard, we mention it as input and output exactly. Then what does this SIN and SOut stand for? Okay. I will explain it later. Okay. Next slide, I will explain. Okay. So now, so this is what the structure of basic input-output operation. Fine. Okay. So now here we got one question like how user inputs are processed and displayed as output. Okay. Example, consider. So here we got a user who is trying to enter some inputs for the system using a keyboard. Okay. So whatever here he is typing, okay, the keystrokes, whatever he is using. Okay. So the appropriate ASCII code will be generated and that will be managed under your data in buffer register. Okay. So now feel that the bus is already free. Okay. So there is no communication in bus right now. So it is free. So that content of this data in will flow to the processor. Okay. So data will be processed. Okay. And finally, it will be displayed in the output unit. How it will be? Processor will send that information to the data out. Okay. So from data out to display unit. Okay. So whatever we are typing using MS Office. Okay. Like simultaneously, we are getting the gesture of those alphabets, whatever we are typing, right? Okay. So in the backend, input unit to processor, processor to output unit. Okay. So this is what we do. Keyboard to data in to bus. Okay. So bus to processor exactly. Okay. In the reverse mode, processor to data out. Okay. Then data out to monitor or any other display unit exactly. Fine. So this is how the input and output operation is to be performed. Okay. So now, like the general working of input and output will be like this. Okay. So we'll see the technicalities, whatever which is residing inside this topic. Okay. So now, first point, program needs user input or operand, which will be managed in memory location. Program needs user input for operation, okay, which will be managed in memory location. Remember, whatever the program we executed up to now, okay, or whatever we discussed up to now in previous topics and all, okay, obviously they are expecting some operands. Is it right? Okay, sometimes it will be like user-defined operand, sometimes it will be any other. Okay, fine. So every operand will be managed or it will be stored under what memory location. Clear? So for storing this operand, we don't have any kind of issues over that. Okay, so whatever the user want to store, okay, he'll be having a front end option called as save. Okay, so if we save, then automatically it will be like memory will allot some location. In that particular location, the content will be stored over. Okay, we don't have any problem if you want to store the information or store the operand in any memory location. Okay, clear? But when it comes for the processor, we have some issues over there. Okay, so we'll see that what issues are faced by the processor over there. The processor involved in processing user inputs. Okay, but speed of processor and typing speed of user have huge gap. Okay. So as I mentioned in previous block diagram, so whatever the user is entering the input, okay, so that will go for data in, data into processor exactly. So here, directly we are involving our processor to process your input strings or input alphabets or anything, whatever we are providing as an input. Okay. But here we got a problem of the typing speed of user and the working speed of the processor. Okay, like millions of instructions can be executed by a processor within 1 second. Okay, then what is the speed or typing speed of a human? Okay, within 1 second, hardly 4 to 5 characters we can type. Is it right? Within a second, hardly 4 to 5 character properly we can type. Is it? Okay. So this is what the issue, what your processor is facing if we get involved in processing the input. Okay. So now we'll see whether do we have any such kind of issues while displaying the output result. We'll see that. Okay. So next point here. For displaying the processor, for displaying the processor data, we don't have such issues because it involves processor and electronic output device. Okay. See, for displaying the result, okay, as the output, okay, what we are dependent on? We are dependent on some gadgets, obviously. Is it right? Okay. Like from electronic medium we are using over here, or electronic devices we are using, like our monitor, like our touch screen, or else your projector it may be, printer it may be, okay, audio speakers it may be. Okay. So these are all what the output units we are calling it as. Okay. So now, yes, we do have some kind of a mismatch in working speed of processor and all those devices like output devices. But when they're comparing it to the human, okay, there will be a huge gap. Okay, when we are considering the input unit, okay, and when we are considering the output unit, okay, there also we are having a huge gap over there. Okay, so before we involve this processor to process our input data, which is entered by the user, okay, we need to think twice. Okay, or else we need to make some arrangement, okay, so that this gap whatever we have that should be solved. Okay, we'll see this, okay, how we can like overcome from this issue and all. Okay, so next point, fourth point, just observe there must be some mechanism, okay, which intimate, okay, there must be some mechanism which intimate processor that inputs are available in input buffer. Okay, so the concept is like whatever the user typing, so that will be available in your data in exactly, right? Okay, so whenever data is available or whenever that data in register is full, okay, then there must be some mechanism which should intimate your processor that data in register is full of input data, okay, which should be processed. Okay, now, like the processor, by this intimation, the processor will grab entire content, whatever is available in your data in register exactly. So instead of making our processor wait for this content to get full, okay, because the typing speed of the user is very less, is it right? Okay. Example, consider like for if I want to full the data in, okay, like I need to type total 20 characters, example, okay, your processor must be wait, like it should wait for at least 4 to 5 seconds. Is it right? Okay, so that the data in register get full over there. Okay, so instead of that, what we do, we are adding one small mechanism, okay, which will intimate your processor that yes, data is available in the data. Okay, no need to wait for entering by the user. Clear? Okay, like processor will be intimated whenever data is available in the data. Okay, if data is not available in the data in, there will be no intimation going for the processor. Okay, then processor will should not be waited for data in to get full over there. Okay, that's why we are saying there must be some mechanism which intimate processor that okay, inputs are available in input buffer. Okay, also output device is ready to display the content. Okay, so there must be some mechanism. Okay, we'll see that what is that mechanism. So we use status control flag. Okay, so in this like previous slide, okay, you can observe S in and S out we are having, right? Okay, so this we call it as status input flag, status output flag. Okay, so these are the few indication, okay, we are using so that we can intimate the processor that whether the data is available in data in or not. Okay, and one more, S out we are using it for like whether the output unit is ready to display the content or not. Okay, I told you, right? Compared to the user, output units are fast. Okay, they are fast in displaying the content. Okay, But when we are comparing the output unit with the processor, still we are having a huge gap over there. The working speed of processor and the working speed of your output unit will be having huge gap. Okay, so what we need to do? We need to go for adding a mechanism both for input and output. Okay, concept is very simple. Whenever user is entering the input, that will be available in data in. Okay, if data in is available with some information, that will be intimated to your processor. Then processor will collect the information and he will start processing it. Okay, then when the output unit is ready to display the content, the processor result will be sent to the output unit, and finally the output will be printed on the screen. Okay, so this is one very simple kind of logic. Okay, just we are using S in and S out to intimate the processor that whether data is available or what. That's it. Okay, so we'll discuss about the S in. If S in is set to 1, okay, remember this is a flag. These are the two flags. Okay, S in and S2. Sorry, S in and S out. Okay, so which are having ability to store one bit of information. Remember this, only one bit of information, either 0 or 1 exactly. Okay, remember S in and S out are the flags which are able to store only one bit of information, either 1 or 0. Okay, now we'll see. If S in is set to 1, okay, if S in is set to 1, data is available in data in register. Remember this properly. If sign or else like the flags of input, if it is set to 1, S in is set to 1, it means that data is available in data in register. Okay, or else we have one more condition. Okay, if it is set to 0 means, okay, if it is set to 0 means no data available. Okay, if it is set to 1 means data is available in data in register. If it is set to 0 means data is not available in the data in register. Okay, so this S in invokes read operation by processor. Remember this. If SN is set to 0, it will invoke the read operation by the processor. So whenever the processor receives SN equal to 1, it will directly come to data in register, and whatever the content is available inside that register, it will be taken back to the processor over there for processing the information. Now feel that, yes, processor has collected some information, okay, from the data in, and it is already processed. Okay, now it should be displayed. Now we'll see whether the output unit is ready to display the content or what. Okay, if S out is set to 1, if S out is set to 1, okay, data out is empty. It means that data out is empty, okay, and it is ready to display the content. Okay, how the display will be, or else how the content will be displayed in display unit. Okay, see, whatever we want to display the result, okay, that should be uploaded for data out exactly. Okay, when we can upload, when it is empty, that's it. Okay, when it will be empty, we need to set our S out equal to 1. Okay, that indicates the processor that data out is free now. Okay, then the processed information, whatever we have in this location, that should be transferred it for S out. Finally, data will be displayed in the display unit. Okay, then what does S out stand for? Okay, if, sorry, it is actually it should be if S out is 0, if S out is 0, output device is busy with displaying the data. Okay, other than this result, okay, if output unit is busy with displaying any other result, okay, then S out will be set to 0, okay, which will not allow the processor to transfer the processed information from this, okay, processed information to data out. Clear? SN is set to 1 means what? Data in register consisting of some value. So it should be collected by the processor, okay, which invokes read operation. Okay, if it is set to 0 means there is no data. Okay, then processor will not come to data register to check whether data is available or not. Okay, so that is what the indication we are providing for input unit. Okay, then later for output, if S out is set to 1, okay, then data out is empty. Okay, means the processor result can be uploaded for data out, and finally it will be displayed, okay, as a result. Okay, if S out is set to 0, okay, which means that the output unit is busy with displaying the other content. Okay, so then processor should wait until S out become 1 example. Okay, so this is what particularly a waiting loop exactly. Remember this. Okay, so this we can implement. Just observe over here. We are having two different logic applied over here. Okay, then we are going to the code. Okay, proper code will be here. This is what the logic. Okay, if you want to read the content, see, this is for the reading and this is for the writing. Okay, this reading is nothing but input. Okay, writing is nothing but output exactly. Okay, read wait. Okay, so this is what a label. Remember, don't get confused. This is what a label. How we had a loop. Okay, this is what a label. Okay, read wait. Okay, we are labeling this read wait for this particular statement. Okay, what is that? Branch to read wait if S in equal to 0. Branch to read wait if S in equal to 0. When S in will be equal to 0, remember from the previous slide, when S in will be equal to 0, when we don't have any input available in the data in buffer register, okay, data in buffer register, then S in will be set to 0, obvious, right? Okay, it means that we don't have any input available to display. Then what I need to do? We need to wait until we receive the input over there. So we are writing this statement, read wait. What is that? It is a label for this particular line. Okay, branch to read wait. Branch to read wait. Okay, branch to read wait. If S is equal to 0, we are checking for this condition. If this condition is satisfied, then what we need to do? We need to go for read wait. So this is what a logic. This is not a complete code. Remember, code will be here. Okay, don't get confused. Okay, if it is equal to 1, then we are violating this condition, right? Okay, no need to go for read wait. No need to go for branch to read wait. Okay, read wait. We need to come for next line. What is this? Input from data into R1. Okay, input from data into R1. If S is equal to 1, that indicates that input buffer register data in is consisting of some information. So that should be transferred it for processor example. Okay, so that is what this statement performs. What is that? Input from data into R1. Okay, so whatever the content of data in we have, that should be shifted for R1. So this is for reading the content from the data in. Okay, then how to write for data out? Okay, same logic we are using. We are labeling this condition as write wait. Okay, branch to write wait if S out is equal to 0. When this S out will be equal to 0, if the output unit is busy with already busy with displaying some other content, okay, then S out will be set to 0. Okay, if this is what the condition true, okay, then we need to go for what? Write wait exactly. Where we have write wait? Yeah. Okay. Remember, these two lines are waiting loop. Okay, these two lines are waiting loop. Okay, here we are waiting for the read operation. Here we are waiting for the waiting for the write operation. If S out become 1, then no need to go for this read wait. We are violating this condition. So we are coming to the next line. What is that next line? Output from R1. Output from R1. See, R1 is consisting of what? Data and content. Okay, so output from R1 to data out. Okay, finally, whatever the user is entering, okay, which will be managed under data in, okay, will be transferred to data out using R1. Yeah, so this is what a logic. For that, we are writing a code over there. Okay, same read wait and write wait we are using. Okay, see here, test bit we are using. It is a new like instruction we are using over here. Test bit. Okay, means we need to test one particular bit. Okay, what is that particular bit? Yeah. Okay, see here, what is that particular bit? This is the particular bit. #3. Okay, means third bit we need to check. Remember, first one, second one, third one. Okay, where you want to check this third bit? Where you want to check this third bit? In status. That is nothing but S in. Okay, that is nothing but S in. Means we need to check the third bit of S in exactly. That is what the meaning of this particular instruction. Test bit, which is that bit number, third one, where we have here. Okay, in which location we need to check this third bit? Okay, in status. In status means S in. Okay, see, 3 bits we are using for this. Remember, okay, to represent this particular like status, how many bits we are using? Total 3 bits we are using. Okay, if Sn is set to 0, what will be the third bit? 0 exactly, right? Okay, let me consider the 0 first. Later we'll go for 1. Okay, so read wait, we are labeling for this particular instruction. What is the outcome of this instruction? You need to test the third bit where in status. Okay, if Sn is equal to 0, then all 3 will be 0. Is it right? Okay, if Sn equal to 0, then all 3 will be 0. Then if you are checking for the last bit, what you are going to get over here? 0 itself. Okay, so I told you, right? Branch statement will check the output of the previous instruction. What is the previous instruction output? Here, after checking the third bit, what result you are going to get? 0 exactly. Branch equal to 0, condition satisfied, right? Branch equal to 0, condition satisfied. Then what I need to do? I need to go for read wait. Where is that read wait? Okay, means until this 0 turns to 1, till that we need to go for waiting for read operation. Okay, same. Again, second time, if still Sn is 0, again you are checking for the third bit. In status means sin exactly. So third bit will be 0. Okay. Then again branch equal to 0, condition satisfied, go for read write. Clear? Okay. Now, if sin equal to 1, then what will be the in status or sin value? 0, 0, 1 exactly. See, this is what the binary representation for value 1. Is it right? So now, if you are testing the third bit, what is the third bit value? 1 exactly. Right? Third bit value is 1 exactly. Is it right? Huh? Wait a second. The third bit value is 1 exactly. Okay. Now, branch is not equal to 0. Now, branch is equal to 1 exactly. But we don't have a condition satisfied over here. Is it right? Okay. So, what we need to do, we need to violate this condition and we need to come back to the third line. Okay. What is the third line? Move byte. Okay. Move byte. Okay. Data in buffer register, whatever we are having inside that 1 byte of information is its maximum capacity. The complete 1 byte of information should be shifted from data into R1. Clear? Clear? Okay. Same thing we are performing for the write operation. Okay. Write wait we are labeling for this particular. Okay. Output status also we are having like out status. This is nothing but S out. Here also we are checking for the third bit. If the third bit is 0, okay, means the output unit is busy with displaying the content already. Okay, so we need to wait till it gets free. Okay. If it is equal to 0, third bit, then branch condition satisfied, branch equal to 0. Then we need to go for write wait. Where is the write wait? Yeah. Okay. Means we need to wait till this last bit turns to 1 exactly. Okay. So now if S out is set to 1, okay, then what will be the result of this S out? Okay. So 1 it will be. So when we are checking for the third bit, we found that 1 exactly. Right? Then branch is not equal to 0, branch is equal to 1 now. So no need to go for this write wait. Okay. So we are violating this condition. So we are coming out of this loop. Then move byte, observe it carefully, move byte, what I need to move, okay, content of R1, which is consisting of 1 byte of data in content, okay, it will be moved to data out. Yeah, so this is what basic input output operations means. Okay, so when they ask in your exam, you need to write that block diagram, you need to discuss about the issue, okay, like what processor is facing while reading the content and while writing the content, okay, like SIN and S out, application of using or else advantage of using SIN and S out you need to discuss. SIN equal to 1 means what? SIN equal to 0 means what? That is must remember. Okay. Then later S out is equal to 1 means what? S out is equal to 0 means what? These all things should be explained properly. Okay. Then you need to come for the code. Okay. When it comes for code, you need to write the both the section, like logic section, like read wait, branch to read wait, if SIN equal to 0. This kind, the first step, and the original code. Okay. Complete you need to write. Okay. It carries 8 marks question. Very, very important. Clear? Okay. Say very simple concept. Okay. So whenever we provide a input for a system, okay, so it will be loaded in a data in. Okay. But the working principle or working speed of processor and this typing speed of user is there is a huge gap, and also the working displaying speed of output unit and processing speed of your processor is having huge gap. So what we do, okay, whenever they are free or whenever data is available, okay, that should be implemented for the processor. Okay, what we are trying to do over here is, okay, no need to make our processor to enter a waiting loop, okay, in waiting of the input data or else in waiting of the output data. Okay, it should be free from all these kind of limitations. Remember, okay. So what we need to do, we need to go for adding some indications, okay, which will intimate the processor that whenever the data is available, it will be intimated. That's it. Okay. So in the rest of this time, processor will be busy with improving its performance regarding the other tasks. Remember, okay. So this is what the advantage of using SIN and S out, and this is how your basic input operation or basic input output operation is to work. Yeah, total 1, 2, 3, 4, 5, 6, 7 different points. Okay, then later these two concepts must be explained. Okay, students. So from next class, we'll go for stack and queues. Okay, so how we can utilize the concept of stack and queues in case of computer organization, we'll discuss. Okay, thank you, students.